All right, today we're going to be looking at finding determinants and Kramer's rule, which will help us when we are looking at doing 3 by 3 matrices. All right, those will be 3 by 3. But square matrices, to have a determinant, that's a number that we need that we can use for different applications that will come up later on in a couple days from now. But really simply, for a 2 by 2 matrix, the determinant is found by multiplying the top left by the bottom right and then subtracting the bottom left from the top right. And you can see the equation that is given to you right there. Now, for 3 by 3 matrix, it's a little more complicated because we're going to be using something called minors and cofactors. So, for example, when I go through and I want to find the determinant of this 3 by 3 matrix that is right there, the minor entry of A, so if you find out where A is, and you think about basically just kind of blocking out that row in that column, we're going to look at making it a smaller 2 by 2 matrix that we can then find the determinant of that. Now, if you go back over here, if I want to find the minor entry of F, so I find out where F is, I block out the row that it's in and the column that it's in, and I say, oh, now I'm going to make it a smaller 2 by 2 matrix, A, B, G, and H, and then I can go through and do my determinant like I did previously, and then I can go ahead and find them for 3 by 3s. So it's a little more complicated, but it's actually a lot of just finding certain elements or certain rows or columns that will make your life easier. Now, one thing that is tricky, though, when you're doing 3 by 3s is something called a cofactors. All right. And so as you look at this cofactor that is going to be over here, it gives us information of to find the value, if it's positive or negative, and I should say positive, I should say keep it the same or take the opposite, they have this interesting equation that's right here that says you take -1 raised to the I plus j, where I is the row number and j is the column number of the entry. And we can use that to find any determinant. We're going to multiply each entry in a row by its cofactor and then add the results. Now, what I simply just say is if it's a 3 by 3, basically it follows this format where you're going to keep the same, take the opposite, keep the same, take the opposite, same, opposite, and then same, opposite, same. If you follow this little shortcut that we have right there, just memorize that. It should make finding these 3 by 3 matrices, which we'll get to in a few minutes, much easier to do. All right. Now, properties of determinants. If each entry in a row or column is multiplied by a constant, then the determinant is also multiplied by that constant. If a multiple of one row or column is added to another, the value of the determinant is not changed. And if two rows or columns are interchanged, the value of the determinant is multiplied by -1. We'll get to those properties in a little bit. Now, if we take a look, all we're doing is just finding determinants. All right, as I said earlier, the 2 by 2 is the easiest one because if I take the top left times the bottom right, I'm going to say this is equal to 1 times 1 minus going the opposite direction, top right, bottom left, 0 times 0. Obviously, if I clean that up, I'm going to get 1 is my determinant. And like I said, today we're just finding the determinants. The next couple of days will actually show where you're going to use them. Okay, so same idea for number 2, top left, bottom right. I get 0 times 1 minus, if I go the opposite direction, again, I got 0 times 1. Either way, if I multiply and add or subtract, I get 0 is that particular determinant. Now, again, these were both 2 by 2 determinants. This was a 2 by 2 determinant. Okay, if I look at number 3, it's also a 2 by 2 determinant. So if I were to multiply top left by bottom right, I'm going to say, okay, if I take 5 times 700, if I go the opposite direction, minus, it's always subtraction, so be careful with all your negative symbols. 7 times 500, some of you can see where this is going right away, because you can see you have 3,500 minus another 3,500. So, oops, make that a little better. Minus 3,500. So ultimately, my determinant is 0 for that particular case. All right. And you can see part of it has to do with because if you take the top row and multiply it by multiply by 100, you get the bottom row. So it's not really working anything. So we're going to get 0 as that final determinant. Okay. We got one more 2 by 2 on the next page. As you look at this one for number 4, as it shows you, it's very similar to number 3. So I'll keep both on the screen so you can see them. So all I did was just interchange the rows and columns. And you can see by doing that, so if I multiply here, 5 times 700 minus, go in the opposite direction, 7 times 500, you can see we're going to get 3,500 for both again. So ultimately, you got 0 for that determinant as well. All right, not as much fun. The 2 by 2s are kind of straightforward. Let's get to the 3 by 3s. This is where the fun gets going right here. So as I start with this 3 by 3, you can pick any row or any column that you're going to choose to get yourself going for this Cramer's rule. So for example, if I just go through and I pick the top row, it doesn't matter, pick any row, any column, you can go from there. So what I'm going to do is, kind of like we did on the front when we were looking at the minor entries to go and figure out the smaller matrices, that's exactly what I'm going to do. So if I start with the 5, okay, if I mentally or with your fingers or if you use a pencil, make sure you erase it. So if I block out that row and that column, what I'm left is with the smaller 2 by 2 matrix of 2, 3, 11, and 7. Okay, and I got to erase that because I'm going to need them for the next part. If I keep going in that row, because once you pick one number, you got to keep going either in that row or that column. So if I keep going in the row, now here's the challenge. If you look at where the 10 spot is, remember on the previous page, remember we talked about how it's plus, minus, plus, minus, plus, minus, plus, minus, plus, right? So we have that situation set up when we're looking at our cofactors. Because the negative 10 is right there on this negative spot, then what I'm going to do is I'm going to take the opposite of whatever that number is. In this case, it's a positive 10, so obviously the opposite would be negative 10. If I block out the row and the column that it's in, I make a smaller 2 by 2 that just has 1, 3, negative 9, and 7. Now, I'm staying in that row. I go to the 15. It's in the positive portion or the positive cofactor spot. So I'm just going to add, right? You can see right there. So I'm going to do 15. Again, block out the row, block out the column. You don't need to physically draw lines through them, but if it helps to make sure you match your stuff up, do it, right? Anything that's going to help you, do it. So I got 1, 2, negative 9, 11, right? So now all I'm going to do is what we did on the front page or earlier with the 2 by 2s. This 5 is coming along for the ride. I'm going to find the determinant of that 2 by 2 that's sitting right there that's multiplied to the 5. So I'm just going to go. Here we go. 2 times 7 minus 3 times 11, right? Okay, so that's the first part. Minus 10 times the group. Now I go the next way. I have 1 times 7 minus the opposite way. Now be careful because you have 3 times the negative 9. Uh-oh, negatives alert. Be careful. Plus, I got one more. I got 15. I do my 2 by 2 determinant like we've been doing this the last couple times. 1 times 11. Uh-oh, there it is again. Minus 2 times negative 9. Right, I'm just showing a lot of steps here. I know some of these you can do in your head. Please be careful, especially those negative signs. So I'm going to take 5. If I multiply, I got 14 minus 33 minus 10 times the quantity of 7 plus 27. Don't forget, you got that negative sign times the negative 3, to the minus 3. So please be careful. Plus 15 times 11. There it is again. Plus 18. All right, no, I'm doing a lot for this one. That's okay. So we don't need to show all our steps next time, but might as well get correct the first time. So 5 times negative 19 minus 10 times 34 plus 15 times 29. So if I multiply all these out, I have negative 95 minus 340 plus 435, which this is a big coincidence. I don't know who picked these out, but you get 0. So you get 0 out again. You can kind of see that if you look at the first row or the second row and you multiply times 5, you can see you get that first in a match. That's why our determinant is becoming 0, because those are just scalar multiples of each other. Okay? Let's try one where it's not like that. Oh, number 6. Perfect. Here we go again. We got a 3 by 3. So you can pick any row or column that you want. It doesn't matter. How about for a little change of pace? Why don't we pick this first column? It doesn't matter what you pick. I'll show you in a few minutes. Sometimes it's advantageous to pick one or the other. Otherwise, it doesn't matter. You're going to get the same answer as long as you're careful with each of your cofactors. So 8 is in a positive spot, so I'm going to keep it as an 8. And then I say, well, if I cross off that row in that column, I'm left with 9, 3, 8, and 6. I'm going vertically now, so I'm at the 3 spot, but that's in an opposite spot. So I take the opposite of positive 3, which is negative 3. Again, if I block out the row and the column, I can say, oh, 4, 2, 8, and 6. Now, if I want to keep going, whatever way I start, I got to keep going. So I get to the negative 2 spot. That's in a positive spot. It doesn't mean make it positive. It just means keep it the same. So I keep it as a negative 2. And then I'm going to cross out my rows and columns. Again, if it helps, use a pencil so you can go ahead and write it back, or erase it, I should say. 4, 2, 9, and 3, right? So we had that spot. Now, I'm going to do not as many steps as I did in the previous example. I'm going to say, well, if I have 8 on the outside, that's my cofactor, right? Then I'm going from there. I'm going to say 9 times 6, right? If I go vertically, go diagonally here, gives me 54 minus the other way, which gives me 24. The negative 3 comes along for the ride. I go diagonally here. So I'm going to say 24 minus the opposite way, right? 8 times 2 gives me 16. The negative 2 again is coming along for the ride. So I can go diagonally here from top left, bottom right. I have 4 times 3 gives me 12, minus the other way, minus 18. Please just be careful how you're multiplying, especially if these are in non-calculator situations. So I have 8. If I subtract, I got 30, minus 3 times 8, minus 2 times negative 6. Careful your negatives. 240 minus 24 plus 12 is going to give me a total of 228. Again, that's a number that we're just dealing with because we're just finding the determinant. It will have a lot more significance over the next few days when we're going to use the determinants for other situations, probably tomorrow. All right, one more time. Here we go, number 7. Now, number 7, remember I talked about picking a row or column that is advantageous to you. What I would highly recommend is you pick this middle column. Because watch, if I start with opposite of 0, that doesn't matter, right? Because negative 0 doesn't matter. But when I do this, if I cross that out, you're like, okay, well, I get negative 37, 18, 14, and 25. If you keep going, now that middle one's in a positive spot. So you cross it out, the rows in the column. And you're like, okay, 23, 47, 14, 25. All right, we'll keep going. Now we're going to get the bottom one here. And that's in an opposite spot. So I have 23, 47, negative 37, 18. But some of you are thinking, whoa, wait a minute. Multiplying by 0 here, you're just going to make that 0. Multiplying by 0 here makes that 0. That makes that 0. So my determinant is just 0. That's why I said if you choose, pick a good row or column, make it advantageous to you. If you see all zeros like that, or some zeros, like I'm going to talk about number 8, I would jump on that because that'll make your life a lot easier when you're trying to go through and save you some time in doing all your multiplications and such. Here it is again. I personally would pick that particular column. You can pick the row. You can pick the bottom row. It doesn't matter. You can pick any column you want. Just be careful with the cofactors. Like, for example, that 0 is in a negative spot. Means take the opposite of 0. Well, we just talked about this. We just saw this, right? Even if you block those out, this 0 here is going to give me a 0 no matter what. So I don't care what the 4 spots are, because when I multiply by this 0 that's in front, that's going to give me 0 for the first set. I don't need to keep on going with that. Let's move on. So the 15's in a positive spot. So I'm going to go through and keep that the same. Now I block those out if you need to block them physically or just mentally block it out. Please just be careful with that row and that column that the 15 is in. So I got 16, negative 64. Whoops, that almost looks like minus sign. Let's move that over a little bit. And then I got 30 and 10. We'll come back to you in a minute. I'm going to finish this up by taking that negative 20, but here it is. It's in a negative spot. So I have to take the opposite of negative 20. So you got to make sure, because it's in that negative spot that we were talking about earlier, the negative cofactor, I got to make sure I take the opposite of it. So it's going to become positive 20, which we'll get to in a minute. Block out that row, block out that column. My smaller 2x2 matrix, 16, negative 64, negative 8, negative 12. So I have that information for right there. Now we're going to start simplifying. The nice thing is that was 0. I'm good with that first one. I don't need to worry about it. So 15. So if I go here, I multiply this way, I'm going to get 160 minus, oh man, they were giving some big time numbers with this one. Well, that number comes out to be negative 1920. But because of the minus sign and the negative, that got a plus sign going on right there. Okay. We talked about out here, we're taking the opposite. So now that's a plus 20. And now if I go diagonally here, 16 times negative 12 is negative 192 minus, if I go the opposite way, 2 negatives do make a positive. So that's going to stay a minus sign, 512. Now we got some large numbers for you to deal with right here. So I have 15 times 2080 plus 20 times a negative 704. Doing my multiplying, adding, going through, punching those out, just to give you a final answer here, we get 17,120 as our determinant. Okay? So, like we said, as you go through finding the 2x2s, just diagonal. If you have a 3x3, use Kramer's rule. Pick a good row or column that will make your life easier. As you saw, like in number 8, picking that 0 that's right here, right? That made things a lot easier for us because it made things simpler. All right. So, and then be careful with your 2x2s and then simplifying all the way down with your cofactors with the positive negatives. All right. I hope this helped. And tomorrow we'll spend another day on it, but we're going to use some more applications. All right. Good luck with your day 8. Keep it going. Good luck.